This is part 2 of 3 parts of navigation for glider and TMG pilots. And in this part, we're going to be talking about navigating in gliders. So, navigating in a glider. With the complexity of airspace in our area, we strongly recommend using a moving map GPS that you understand when you're navigating cross-country. You have to learn to do that on the ground or in the sim. Most gliding systems are pretty complicated to use. Carrying a second moving map, for example on your phone, if that's not where your first one is, can be a very good backup in case the first one becomes unserviceable or runs out of power. A paper map suitably folded and marked is another good backup. But being able to navigate using pilotage techniques, that's comparing with what's on the ground with what's on the map, is a last step. It's fun, but it requires practice to be good at it. So let's look first at planning a task using a moving map GPS. So the first thing we need to do is to review the Notams and the weather prior to planning the task in order to determine what we might do. Then we plan a task in a way that avoids us getting tangled up with airspace restrictions. That can make quite a big difference to the flight. We mark up a map with the task and the wind, and we review key features of the route and the airspace on it. We start with Notams. There are a number of sources of Notams. First one is the AIS, and if you Google NATS AIS Notams, you can find those. You will need to sign up for an account. The problem with those is that they give you a difficult to read, unfiltered, multi-page text output. So although they're authoritative, they're the source, they're not really recommended as a way to understand what Notams might affect you. The one I use if I'm gliding most of the time is Spine, the Soaring Pilot's Intelligent Notam Editor. It's a pretty easy to use graphical interface. You need a PC to run it, and you can get the relevant Notams into your nav system, and I've written up how to do that on this link. So I find that pretty good. What I like about it is it's quite easy to delete all the Notams that aren't particularly relevant. For example, there's an increasing number of Notams about models flying or paragliders flying, and I generally get rid of all of those so that I just leave the things that are important. There's a website called Notam Info. The link is there, and that's quite a good graphical interface which you can get a fairly easy to understand list of Notams, but you can't do quite the same thing in terms of deleting the ones that don't work. If you go to Airspace Select, AS Select, which is a really good source of airspace information, on there you can find the day's Notams in the form of a PDF map and text. And that's not a bad way of getting at them if that's what you like. Also, when we have restricted area temporaries, or RATs as we call them, you can get Airspace Files which have the correct shape for those RATs. So rather than just a big circle, much bigger than the actual airspace itself, which you'll find on some of the earlier Notam maps that we've discussed, here you can get exactly the right shape and the right boundaries, and you can put that in your nav system, so that's very good. And then lastly, Sky Demon has the full version, which you might have, particularly if you're a power pilot of any sort, but it's got a light version as well, and that's quite good for Notam cover, particularly for a narrow route brief, and that's shown on a map. As far as the weather goes, as glider pilots, we have several good sources of weather, and the list is very long, but there are two services that many pilots use. One's called Top Meteo, the other one's called SkySight. They're both subscription services, and there is RASP, which you can find links to on the Grandstand Cambridge Gliding Club website, or you can, if you Google RASP Stratus, you'll find links to that, and they're all quite detailed gliding forecasts. If you link those up with CU Desktop, which again is a subscription service, you can look at your task and the weather at different times of the day, and that's quite a nice integration in terms of planning a task. So far as a glider pilot is concerned, we often spend time looking at the task, looking at the weather, trying to fit a task into the day, and seeing what might reasonably be a good thing to try. Then we just look at the airspace. So if we take, for example, the Club 300, Gransden Lodge, Soham, Eastwell, Calvert, back to Gransden Lodge, and this is an output from CU. We can see Gransden Lodge here, where we're going to start, and off we go to Soham and then northwest. And we can start looking at and thinking about the pieces of airspace that we're going to fly through. So the first thing we're going to fly through is the Cambridge Radio Advisory Zone. That is a zone that we have agreed that we will give Cambridge a call on the radio, so we need to be planning that. If we go into the ATZ, we'll need to get an approval to do that. So we don't need an approval to go through the radio advisory zone, we just need to talk to them. But we do need an approval to go into the ATZ. As we get to Soham and out, we might well be inside the Lakenheath mats, so we're going to need to talk to Lakenheath radar. Again, this is a courtesy rather than a requirement. Later on, as we pass Petersborough, we have a few things to take note of. We have the Wittering mats. Similar comments apply to the ones I've just made about Lakenheath. And we have the Wittering ATZ. We've also got a drop zone at Sibson. If we're a bit west of track, that might come in, and we don't want to fly through that without checking that they're not parachuting. As we come south from Eastwell, we have these pieces of airspace here, and you might notice that I've found a way to show the bases of these pieces of airspace, and when in red they are altitudes, so this is 2500, 4500, and in grey they're flight levels, so flight level 7.5, flight level 6.5. And this I've done with an airspace file, which I can tell you about. But without that, actually, if you're just looking at these red lines on your moving map, you're not really sure about what the base heights are, so that can be a little worrying. And then, as we turn Calvert Rail Junction and come back, there's a few things to look out for. We're going to be passing through or close to Cranfield's instrument approaches, so a call to them and a basic service is going to be needed. But later in the day, as typically we might be by the time we get here, we're going to be a bit high, and quite often we might be at 5,000, climbing to 5,000 feet, 5,500 feet, and we've got to pay particular attention to the London airspace and the Luton control area. And in particular, this bit here, which has a base of 4,500 feet, can get in the way. Or if we're pushed south of track, this one's even worse. This has a base of 3,500. So beware traps like that, because if you find yourself coming up from Calvert Railway Junction and you're a bit south of track and you're climbing to 5,500 feet, which is okay over here, you're going to struggle as you come through this piece of airspace, and if that catches you by surprise, it's a little bit tricky. We need to ensure that we've got up-to-date airspace files and airfield frequencies to hand in the glider. A few ways we can do that. The airspace file we can get from Airspace Select, and that's quite a nice way of doing it, partly because we can be quite selective about which things we want to see within that airspace file. I publish frequencies in a few files, so we've got the BGA turning points file and the airfields and outlandings file, and between the two of them That gives us all the airfield frequencies we might need, or at least the initial contact frequencies. There's the BGA gliding frequency reference card, which is in the same distribution package as the turning points and airfields and outlandings files, and that's a piece of paper with gliding airfield frequencies on should we need to land out at one of those. And NATs publish frequency reference cards for airfields. So if we're just working off pieces of paper, we can take these last two. If, though, we put the frequency file into the moving map, it ought to be possible to access the frequencies from there, but you need to work out how to do that. And another hint, make sure you understand how and when your nav system will alarm when you're near airspace. That alarm can be extremely useful to keep you from trouble. We mark up a map with the track and the wind, as you can see here. So a few things that we can do. This is the Club 100, Gransden, or in this case Caxton, to Rushden, to Ramsey, and back to Gransden. And we've used circles to cover the turning points so that we can see the detail. And we've put little 10-degree track lines in so that we can make an estimate of how many degrees we are off track for the destination turn point. We can stick some pieces of paper on the chart with the true track for the leg, the distance of the leg, and allow us to write what we think the time might be, or times that we've turned different points. And here we've put the wind speed and direction of the wind so that we know what that's going to be when we're in the air. If we look at flying the task using the moving map, we don't want to have our head down looking at the map all the time, so we fly visually. We pick a feature in the distance and track towards that. And we still need to make an allowance for the wind in where we're pointing. So even if we can see the place where we're meant to be going, if we know what the drift is likely to be, we can offset to one side a little bit. And then we point at that, and that's the way we keep our track right. And then we can cross-refer to the GPS to make sure that the track is coming right. And it's particularly useful to have that visual reference for setting our heading after a thermal. Because we've been going around in circles, we don't have a good heading reference because any compass that we're using is still spinning. The GPS will be lagging quite seriously because of the rate of turn. So knowing what thing we want to point at the top of the thermal is very useful. Anytime we go head down to look at a map, to look at the GPS, we want to look out well both before and after we do that. We've got some nav tasks we want to carry out very early in the cruise after the thermal. So a gross error check first. So we take a thermal to whatever height we're going to climb to, and we set off. Well, the first thing we want to check is that we're going in the right direction. So some big feature that we know where it should be in relation to our track, make sure that's there. The big feature might be the sun. We might modify our route plan if we've drifted to one side of track, so we've got to change that route plan, so we might think about that. And we might decide what radio frequency we're going to need next, so get that in the radio and maybe call the air traffic service unit that is on the end of that frequency. Eat something, drink something, have a pee, whatever you need to do. The time to do all this stuff is when you're high and going in the same direction, not when you're low and struggling to climb. Remember, we drift while we're thermaling, so we've got to make extra allowance for that drift. It's not just enough to compensate for 1 times the maximum drift. we need to aim off a bit more to compensate for the time we spend in the thermal. If we get a choice, it's better to route into wind rather than downwind, because the wind will tend to blow us back onto track. I think I'd advise not to overcomplicate the GPS setup. Keep it nice and simple. Here's the arrangement that I've set up for the club Udis that we'll be flying with in the Percos, and I've kept it pretty simple. So here's us in the glider. We're flying track up. So here's the north up arrow, so north is over in this direction. I like track up because then I can correlate what I see out the window with what I see ahead of me on the map. This purple, there's this pinkish purplish line here is the direction to our intended turning point. This blue line was the originally intended track, and this grey line is the direction we're going in. So if I turn so that this grey line is on top of this pink line, I will end up at our target. That's pretty simple. Down here, in terms of these nav boxes, I've got what the target is, in this case Rushden, how far away it is, and how much I've got to turn. So I've got to turn 14 degrees right to get to Rushden. I have my current track, 286 degrees. I've got my height above ground, really useful cross country because it's much better than trying to estimate that by eye if you need to land out. And I've got my required lift drag for the target. And in these green boxes next to landable airfields, Abbottsley, Little Staunton, Bedford Airfield, Sackville in this case, and there's one over here, I have the required lift drag for those things. So this is actually the angle that I'm making to Abbottsley, the angle I'm making to Little Staunton, and I consider 20 to 1 to be reasonably safe. I'm going to make 20 to 1 over that sort of distance in a glider that normally will do something between 35 and 50 to 1, depending on which glider I'm flying. I don't have any margin on that, so I might arrive quite low, but it gives me some comfort that I can get there. And if I choose an airfield as my target, then I'm going to see what that required lift drag is down here, and I can tell what I'm doing at the moment. So pretty simple GPS setup with just the key things that I need, not lots of stuff that I don't. So if we don't have a GPS, how do we navigate? Well, that's called pilotage. In a glider, we can't fly a specific heading or track for a specific time, which is what we would do in a powered aeroplane. We have to route where the lift is, and we have to stop to thermal. So dead reckoning techniques don't work for us. We can decide what the track we want is, and we can allow for drift when choosing a heading, and then that lets us point at a point on the horizon and spend most of our time looking out. So that's all fine, but how do we know where we are? Well, we have to compare features on the map and features on the ground to work out where we are. We can work from the map to the ground if we know roughly where we are and look at what's ahead. And we need to maintain at least 3 known fixes which change as we move along the track. If we are lost, we don't know quite where we are, we'll work ground to map. We'll look for things on the ground and we'll try and find equivalent things on the map. So let's see how that might work. So here's a map to ground example. If we're where this red triangle is, pointing this way, we ought to be able to see some nice big features. So off in about our 1 o'clock, 2 o'clock, close to 1 o'clock really, we've got Grafham Water. Well, that's pretty big. We're not going to miss that if the visibility is anything like reasonable. Down underneath the underneath the left wing, we should be able to see St Neots, and that's going to be a town with water running through it across our track, and a major road running the other side of the town, and a railway running this side of the town. So 3 good features on top of St Neots that will allow us to identify it. And then we have an airfield just left of the nose, Little Staunton, which we ought to be able to see. And that, if you know what that looks like, that stands out very well. In this case, a concrete runway with a lot of solar panels all around it. And then as we move forward, the 3 features we try and keep an eye on will change. So as we're up here, we've got Grafham back over our shoulder. We've got Sackville Farm, another airfield, off to one side, and Bedford on the left wing, perhaps. So 2 airfields that we can positively identify, and a lake is a pretty good set of features. And by maintaining those 3 features as we move along, we can identify our turning point as we get to it. If we're a bit lost though, we need to look for features we can see on the ground and then find several distinguishing characteristics of them and then compare that with the map. We don't do it the other way around because it's quite easy to look for things on the map and then decide and then find them on the ground, but get it wrong. So in this case, here we are. We've got a view out the front of the aeroplane. We've got a biggish town here, which is sort of triangular. We've got quite a lot of water that runs on the other side of it. There's an oblongy town to the other side of the water, and there's another big town beyond the triangular town. So 3 towns, some water, there's another town down here, and another one over there. So we've got quite a few features that we can have a look and see what might those things be. So there we go. There's a triangular town, 2 other towns, a body of water. Where might that be? Well, if we look on the map, here's our triangular town. On the other side, we've got another town off just to the right of the nose, a big town, the little town that we saw earlier, and the body of water that goes through. And actually we can see a disused rail line here on the map, and if we look hard as we get closer, we can find the trees that often run along a railway line. So those things will allow us to position ourselves about here on this map. What about the effects of visibility and light though? As we get lower, we can see less far. Smaller features look significant, but might not be on the map. Also, our radio range is lower if we're trying to talk to somebody. As visibility decreases, we can again see less far, and in both cases, we have to work with fewer clues. There's a danger of trying to identify small features that aren't on the map. So, little villages and things. It's very difficult to tell one little village from another, so beware that. If we're looking into sun, the visibility tends to be worse, and if we have cloud shadows, they can obscure ground features which we can then miss. So airfields don't always stand out very well, for example. So as you get lower, the problem generally becomes more tricky. If you're lost, what can we do? Well, we can make some estimate of a circle of uncertainty. So if we know what our last known position was and when, and think about what we've been doing since then. Have we been drifting with the wind, or have we been cruising, and if so, in which direction? So we've got some area where we should be, and we can look in that circle rather than looking all over the map. Don't forget that you can use the radio. If you are genuinely lost and you don't have a working GPS, the first thing I would do pretty much is call London Centre on 121.5. Tell them you're lost. They won't be judgmental. If you're shy about telling them you're lost, ask for a training fix. They'll give you a training fix. What you say is London training fix, training fix, training fix, London Centre, glider, ABCD, training fix. They'll tell you where you are, and they'll ask you if you want any further assistance. So you can say, could I have heading back to Granston Lodge, please? And they will tell you how to do that, and they'll stay with you until you get back to Granston Lodge if necessary. Whatever you do, don't risk straying into airspace. A few tactics if you're flying cross country. Always have a plan B and a plan C. If this thing I'm doing doesn't work, I'm going to do this other thing. And if that doesn't work, then there's this further other thing. Don't always be committed to the thing that you're trying to do working. Never put yourself in a position where you don't have somewhere you can land. Even if you've got a turbo, the turbo may not start. So if you're high, a generally landable area is okay. But as you get lower, you need to start looking for specific fields or groups of fields that you are confident you can land in. As you get even lower, have a decision height when you're going to land whatever. And when you make that decision, carry it out. Do it all early, not late. The reason people hurt themselves and break gliders is they leave these things too late, and they're trying to make an irregular approach into a field from too low. Don't do that. Exactly how high is in this case depends on the state of the fields. Some times of the year, pretty much any field is landable. Sometimes of the year, you've got to look hard and long to find one. I have turned 90 degrees because the direction I'm going in, I couldn't see safe fields, and I knew that 90 degrees from that track there was a landable airfield, and I've ended up landing at that landable airfield. It was the safe thing to do. If you can fly having a known good landing place or airfield in safe glide range, that can really take a lot of pressure off you, and you can do the other things that you need to on the flight. Manage your workload by doing all the tasks like selecting airfield frequencies and talking to them when you're high and not under pressure. That's quite important. And when you decide to land, stow your map, secure and configure the glider, and just focus on the landing.